I'm going to begin working on the Chapter 6 R assignment. The first thing I'm going to do is create a scatter plot of the relationship between the variables essay and hours. You can see right here, I'm starting with the ggplot function that will specify the object for the plot. It's going to take data from the essay marks data set, and then the variables. The x-axis is going to be hours spent crafting the essay. The y-axis is going to be the percentile score received for the essay. And then I've added the geom_point function here to add the visual element of the data plots onto the scatter plot, and then the labs function will add the titles, which you can see I've written in there. So I'm going to go ahead and run that. And you can see the graph pops up down here. The next thing I'm going to do is conduct Shapiro-Wilks tests to check whether the hours data and the essay data are normally distributed. So you can see I've already put that in here, and I'm going to go ahead and run that for hours and then also for essay. You can see that the p-value for both of these is greater than 0.05, which means that this data is normally distributed and does not differ significantly from the normal distribution. So since the data is normally distributed, this means that when I'm going to run the correlation next, I'll be using the Pearson correlation. I am going to run a one-tailed correlation test on this, and the reason for that is in the assignment it does say that we're interested in finding out whether there's a positive relationship. So we're specifically going to be expecting or looking for a positive correlation here. So we'll be doing a one-sided, and you can see that that's in the code here. I'm going to be using the function core tests and looking at hours and essay variables from the essay marks data set. I've set the one-sided test using alternative equals greater here to look at the positive correlation. So we're testing, our hypothesis will be that the correlation coefficient will be greater than 0. And then the method, as I said before, since the data is normal, we'll be using Pearson. And you can see the output down here. The correlation coefficient is 0.266 or 0.267 if you round up, and the p-value is significant at less than 0.05. It came out to be 0.038. So next I'll be looking at the grade and hours variables from the same data set and running the correlation for that. The difference here will be that instead of using the Pearson correlation, I'm going to be using the Kendall correlation because the grade data is ordinal rather than interval data. So let me go ahead and run that. You can see here that the tau coefficient is 0.158, and the p-value is greater than 0.05 at 0.089. So that means that the correlation is not significant. Next, I will be looking at a different data set, the Chick Flick data set. I'm going to be looking to see if there's a relationship between gender and arousal, and to see whether or not the film watched and arousal have a relationship. So first we'll take a look at gender and arousal. And for this, I'll just be using the default in R, which is the Pearson correlation, because this is a point biserial correlation, since both gender and film for each of these correlations is a dichotomous variable. So I'm going to go ahead and run both of those. So you can see here that there was not a significant, that the relationship between gender and arousal is not significant, which means that we can't be certain that the relationship that we see is happening by chance or not by chance. Second, down here, however, looking at film and arousal, the relationship between which film the person watched and how aroused they became was significant, with a p-value of 9.4 times 10 to the negative 6. So there's actually a fairly strong positive correlation between the two that we can say with a 95% certainty does not happen by chance. So finally, I'll be looking at the grades data set and looking at the relationship between GCSE math grades and first year university statistics grades. So this data is ordinal, which means I'll once again be using the Kendall test for this correlation. I'm also going to run a one-tailed test just because of the information given in the description and the task. I would assume that as the GCSE score goes up and your greater preparation in secondary education is better in math, you have a better previous expertise with math, you would end up having higher first year scores in your statistics class. So once again, you can see I've set for the one-tailed test, the alternative is greater because I'm expecting it to be a positive relationship with a correlation coefficient greater than 0. So go ahead and run that. You can see here that this correlation is significant. The p-value is 0.015. So there does appear to be a relationship between the grades on the GCSE in high school at age 16 and the first year university stats grades. So that concludes this homework assignment for Chapter 6 in R.